released for and traded in a specific market. So of course, what is in there: application, the market, software components, and the package. Like I said before, you guys won't be selling just a product, or maybe you are selling a product, but you're selling a product plus a service. And the service may be part of the product, or some other company might be providing the service and you guys specialize in the product. Well, something like that. What we are going to talk about today, I'm going to keep it very short, is a startup study. Was done by Carmel in the late 90s. Very, very interesting. This Carmel guy is sort of a high guy in the is a guy who has a lot of weight in the area of product software. And so here you see some papers by him, and he studied 12 starting product companies, but quite large ones, from I think 5-6 people to 50 people, that with some funding are trying to develop a product. And he tried to look at successful approaches in the acceleration of software production. So of course all these companies, especially back then, are running into trouble building a product, are running into trouble getting things delivered on time. So they're really doing the best they can to quickly build that product. And also, yeah, tailor-made software world, software is always late. This was especially true back then, because we all know that especially Windows had a tendency to be delivered 2-3 years after it was promised. Nowadays they're doing better, and I think other companies are following that as well. Well, there are a whole bunch of papers. But first let's take a quick look at this movie. I think it plays if I click it on this. So. See if we have volume. Huh. One big downside of Google customizing search for everybody.
6 months? At least. 1 month to build the product and 5 months to play games on my computer. 1 year, unless you add people to my tiny empire. 18 months! Two months, and it solves every problem you have.
Give me the beta test version in 1 month. Cardboard? That's stupid.
Oh, then it's beta.
Well, it's a nice little illustration. Alright, so let's talk a little bit about the process of developing a product. I think many of you have a picture of how this goes. I think many of you have already started this. But what Carmel came up with was, okay, we have a requirements loop and we have a quality loop. For those of you who know me quite well, you know that my PhD thesis was about mostly about this. So about the day that you say, okay, now my product is finished, how do we get it to the customer? Yeah, and so basically you design and code until the quality threshold is reached. At some point you say, okay, now it's good enough, now we can go to market. There, of course, also underlies this problem of constantly delaying delivery, because you're constantly thinking, well, if we wait 1 more week, we can also build this and this and this. With Lifecycle, we delivered, I think, a year after we supplied our first delivery, simply because of, you know, oh, we need to build in this as well. And we tried changing requirements as well, so we kept on thinking, if we do have to do this later, when we already have paying customers, then life's going to be too hard. So sometimes I'm quite happy we make those decisions, even though we are a year late. So here's the requirements loop in detail as he found it in these startup companies. So first of all, there's the idea. I think we're all in that phase. Some of you are a little bit beyond it. Then your preliminary requirements, some screening. One of the most important things that I think are terms that I don't use enough in the presentation, but is relevant, is minimum viable product. And by this I simply mean something that you can show, like, okay, this is how we would be making our money. Your prototype will have to be sort of an MVP, minimum viable product. So you do your initial screening based on some criteria. For instance, this is going to take too long, or that is not super important, that's like an extra feature. Also based on customer feedback or potential customer feedback. If they say, wow, we don't really need that feature, then that's a good reason not to build it in first. And then build a prototype and refine and keep coming back, show it to customers. Well, internal review, external review, so like I'm saying, you can show it to your teammates, and of course show it to some external users. I think Spotmeister did a great job of the first version because it never crashed on me. It always worked. Maybe showed a couple of small things that I thought, oh, that's weird. I kept saying, getting the same questions. Such is life. Then at some point freeze the specifications, and then, well, you can do something with those frozen specifications. Typically send it to the sales guy so that the sales guy knows, okay, this is what I'm selling, and that he's not over or underselling your product. Then of course there's the quality loop, also a fairly typical development process. It's not very agile this, but don't forget this was 95. Well, design code, so we were still, we didn't have a larger prototype than maybe a throwaway prototype, and now we're really building a production version. Alpha test, again defect removal, beta test, defect removal, final testing, and then you send it out. Very traditional way of looking at software development, almost waterfall-like. Of course you can go back on a number of points here. Alright, so a bit of background again on this study also. Well, release of a new car model takes about 36 months. I think this is actually, back when we made this presentation, it was actually 48 months. I think 36 is now more realistic. Release of a new printer used to be 22, now it's, I don't know how quick these things come out like crazy. But they didn't know for software products how quickly do they come out, even nowadays, because it's such a, how do you say, it's like a bestseller. I mean, some bestsellers are like this, some bestsellers are like this, but you know, they take different times to come to fruition. And of course, you need to sort of have this kind of data because it makes life easier to get your R&D investment back and maybe also do faster cycles of product renewal. So if you can speed this up, life is better. We all know this by now because many products develop very quickly. So productivity, how do you measure productivity is of course a very tough question. Well, it could be effort per time unit times person. So for instance, lines of code, but I think many of you know that lines of code is really hard to talk about. Yeah, again, Wilbert, I feel your pain. I feel exactly the same way about this. One measure that I really liked when I heard it from ASML is that they have C code for all their wafing machines, if that means anything to you. But and what they say is that for every 100,000 lines of code, they need one full-time maintenance person. Now that I find a very nice way of looking at things. But of course, if you have this with Ruby code or Rails code, then I think for every 100,000 lines, I think you may even need more engineers because this code is much more expressive. So you can say much more in 100,000 lines. I don't think native side goes beyond 20,000 lines or so. So it's not, well, I don't know actually. This was back in the BAM days, they sort of kept up with this 20 lines of code per person day, which seems very little, but I wouldn't be too shocked if that was still true, even if you're writing Rails code or PHP code or whatever, simply because for every line of code you write, or every 20 lines of code, you'll maybe introduce 2 or 3 mistakes. Or, well, in terms of maintenance, of course, as soon as you write something, later on you have to maintain it. Well, one thing about metrics, I think in this class it's not so relevant yet, but especially in companies this is a really good point. I think, well, you have to have a very professional atmosphere when you look at metrics. It should never be like, oh, Wilbert is creating 100 lines of code and Thijs is creating only 20, so therefore we should fire Thijs. I think it's actually quite a good example because Wilbert will be writing a lot of buggy, crappy code. And Thijs is writing very eloquent, beautiful code. That doesn't work again, but that's because he's Thijs. I had to say something nasty. So you can't use it against each other.
It's all on tape.
What was that?
It's all on tape.
It's all on tape. Ah, very good. So, and of course, precision of data is not an issue. I mean, you don't have to benchmark yourself against other companies. The only thing you want to do is benchmark yourself within a company, but also look for the reasons why is Wilbert creating 100 lines of code and Thijs only 20. Maybe Thijs has management responsibilities next to it. Maybe Wilbert is just a better programmer, because I think many of you may know that some programmers are, well, programming is like, how do you say it? It's a very skewed scale. So a mediocre programmer like me will create maybe 20 to 100 lines of code per day, and there will be lots of bugs in there. A very smart programmer can create the same amount of code, but with no bugs, or maybe just with using the right expressions to express the right things, and just be much more productive simply because of more experience, knowledge of the platform, etc.
So there's also the Pareto principle,
yeah,
that 10% of people will do about 90% of the work,
exactly.
And that's been found again and again. So
yeah, yeah. Well, it's a very true point. I thought that would be on the next slide even, but yeah, no, this is a very true thing. Also, you see that in a company where software is being developed, usually there's one core team of 4 to 6 people. They do most of the work, and then there's a whole bunch of people around it who are juniors or people with less experience who are building, extra features for which a lot of money can be asked. But it's the core platform that's being maintained by these 4 or 5 guys. Well, I'm going to skip this slide because most of this is already known. So basically what they did was literature review to find things that speed up development, like your development methods, development team, and resources. Mythical Man Month, does everybody know this book? You should. Basically, the mythical part means, very good, I see the right people shaking their head. The mythical part is that if you add 1 man month to a team, so you say, okay, you have 1 more month to make the deadline, here's 10 more people, then you get to make the deadline. That's ridiculous. That's never going to work. Also from literature, project management, so make sure you give, some of you may know Jules Polski. I think I introduced Agile guys to him. He's a guy who once said that developers are rock stars. And this has been sort of an adagium, a motto of the industry nowadays, that you should treat your developers as good as possible, because every second that they're busy developing, they're making so much value, whereas every second they're trying to get a better computer or a better screen, they're basically wasting their time. So you should treat them as good as possible. And a good project manager does that. So they give them agile development touch screen with, that's good management right there. Also risk analysis, so beforehand do a good analysis of what can go wrong during your project. I actually have kind of a horror story that was finished I think last June or so, where I was involved in an outsourcing project that went very, very badly because the manager, I'm not going to mention any names, but it was me, never looked into the code. So I just looked at the functionality, and the features were working okay, not coming along very quickly, but I thought it was okay. And then at some point I showed it to a developer, a friend of mine, saying, why is it not speeding up? And the guy looked at the code and said, dude, this is the worst code I've seen in years. These are people using the Rails framework without using the Rails framework. So they're constantly using the wrong keywords, they're doing their manual routing, which in Rails is done automatically. So, well, that was bad project management. And I should have done risk analysis beforehand, where I knew that I was not going to look into the code because I cared about the features. So, well, those kinds of things. And of course, incremental innovation. So get that minimum viable product out there, sell it once or twice, and then get from feedback customers, let that sort of steer you in the right direction. Of course, think about the faster horses principle, but see if, because then quickly you can start incrementing your product and making it better and making it more money, hopefully. All right, so the research method, well, 12 cases, we'll not go too deep into it. Here you see some of the domains, so very varied, even some games, I think. I couldn't say that. So here you try to establish whether there was sort of an average in development time for each release. So, well, there you can see firm number 1. You see, oh yeah, so they don't remember how long the first product took, but the subsequent products each took 24 months to build. There you see 26 months, and the second version in development. First product 5 months, and you can see, especially from the first product, very high numbers. Later side, same story. It was in the end it was 2 years, or maybe even 2.5 years before we had a first version out there. Also very interesting. Many people don't really have a time strategy, and the only thing that made people work faster was competitive pressures. Seeing, okay, the competitor just came out with X. So we really need to soon come out with something, because otherwise they'll be all the way over there by the time we come out. Some nice averages, subsequent releases 14 months, and each separate release 26 months. Of course, nowadays with this incremental style of development, you try to deliver every month, and that has improved these numbers significantly, I think. So, well, one of the first things they looked at was the development method. Oh, you can see, let me see, did they do any prototyping? None, 3, little, rarely, 1, and prototyping actively used. I think prototyping now is the way to go. I mean, you try to deliver every month, you try to get customer validation every month, or if you're really Scrum, you get a customer on site to help you with development. I've worked that way, and it's incredible for what it does to development, because the customer is constantly looking along and going, why does it do this? They ask the sort of stupid questions that need to be asked, and really great. Okay. Well, lifecycle models are accidental. I think this will happen to you too, where you think, hey, every 2 weeks we deliver a new version. Maybe that should become the process. Also, after 0.1 or 1.0, that's when there's sort of more of a methodical way of going about it. In the beginning, it's just crunch time and you try to deliver something quickly. I hope all of you will be the same way. That, you're going to try and get that final prototype to look perfect, minimum viable product, and sell them. Well, the entrepreneurial nature of the firm also determines the development method a little bit. Shortage of money means no money for project management tools, means no money for expensive touchscreens, means so these things really determine development method. Critical events, and method is typically not in the culture of software firms. I think, well, there's no news for you. Some of you are developers and you know, I just want to build something, and when it's done, it's done. And especially for hobby projects, this works really well. So importance of the software architecture, usually not on paper, especially in a startup, however, really important. The one thing I missed from your guys' product definition was sort of this architecture of the mobile app and the desktop app, and I wanted to hear more about it, and I think in a week or so you'll be talking about those issues. How is the desktop app going to look, how is the mobile app going to look, how is the web app going to look, and the whole architecture behind it. Well, use of prototyping, mock-ups, demos, proof of concepts. I've been many times to trade fairs, and it's really great to see people show off their new features. Because something always goes wrong, but they try really hard and go like, wow, these are all the cool new things we have. So for you too, I was actually expecting some of the product definitions to contain a mock-up or something, or like a screenshot, something that would kind of give me an insight of like, okay, that's how it's going to look. Nobody used that opportunity. What was that? Oh, I thought somebody said something, had a good suggestion. Overlapping phases, so either that's poor planning or it's just being more agile. Well, I want to talk about this, but we can do that later. Yeah, I think I'll finish on this note. I think one of the most important things to any software firm is the core development team. I already mentioned that there's usually 3 or 4 guys that sort of build the company. One thing that I found really cool is, for instance, Exact, which has, I think, now 1,500 employees, could be a little bit less, could be a little bit more. But they have a core team of about 12 developers that they put together for new generations of the new product. So even they, a company with such a nice method and such a methodical approach to making money, they still have this core team where they basically say, okay, here's some time, go make something beautiful. This is where we think the market is going. We put a very nice visionary product manager on it, and then he just controls his development team. And that's how Exact Online, for instance, was created. That's how eSynergy was created. That's how Exact Global was created. So even with 300 developers in Kuala Lumpur, they leave core development of new features, new platforms to this crack team. Typically fairly homogeneous, so all white males between 25